Hey everyone, welcome to problem number 14, longest common prefix. Okay, it's a easy difficulty one, asked in a couple of Amazon, Apple and Google interviews. Write a function to find a longest common prefix string amongst an array of string. If there is no common prefix, then return an empty string. Okay, so what are we trying to do here? Given an array of strings, we just have to see what are the common prefixes. So for between these two, the common prefix would be FL and O, and then FLO would kind of match with FL, and the answer would be FL. Similarly, if it doesn't have anything, we of course gonna be returning empty. Okay, what are the constraints? So the string length, the array length goes from 1 to 200, and each string inside the str's array could go from 0 to 200, so it could also have an empty string. And each string in strs array consists of only lowercase English letters. So that's pretty much it, and let's start coding. The first approach that comes to my mind is of course the brute force. So what we would do is, let's start by writing base conditions. So if ln of strs equals 0, then we would return an empty string. If length of strs is equals 1, then we would return the first string. Fair? Pretty straightforward base cases. Now we have kind of made sure that the strs would have the minimum of 2 and onwards. Okay, so what we would do, say imagine we have two strings. Check for prefix. Okay, oops, s1 and s2. How would we know what is a prefix? So what we can do here is, let's do something like this. I equals 0. I'm just writing a brute force solution here. So while I is less than ln of s1, oops, and j is less than ln of s2, then what we would do, we will just add prefix oops if s1 of I is equals s2 of j. So we are checking pointer by pointer. If they match, then we will just append in s1 of I mean s1 of j and s1 of I are same, so we can just do something like this, and I plus equals 1, j plus equals 1. And if they don't match, if what we could do, else we would just break out of the loop. At the end, oops, we will just return the prefix. Fair? So we'll start, say I is at f, j is at f, they match, we'll increment L, we match O, W, W, they match. Now j is kind of greater than the length, that's why it would anyway come out. And the first, if these two are under consideration, then the prefix is going to be flow itself. Okay, so yeah, previously I might have said something different, but now I know with all this one. Okay, so now what we can do is say common prefix equals empty, and instead of that we could just do this, common of prefix, because we now know the str minimum is 2. So what we can do, check for prefix, str is of 0, strs of 1. So at least we have something to start with. And for string in strs of 2 to everything else, if there is a common prefix, then common prefix is equal to check for common prefix, comma string. So now next time the common of these two, that is flow, is gonna get matched with flight and rest onwards. Okay, that's how you basically come out of it. And then return common prefix. Okay, let's give it a try. Okay, and submit it. And everything is accepted. Okay, let's try to take a step forward and come up with a better approach. Okay, so maybe this is a good time to learn about a new data structure called try. If you like, we all know the basic ones, of course, the arrays, lists, dictionaries that are built on top of those. Stack is of course there, skew is there, trees are there, graph is there. But then there is something called as try. Let me see if I can find some try using it. So what do we do in try? Well, basically, when do we use try? Say when we make some suggestions, these are the what am I. So what am I, and all these recommendations, they are based off. So in the backend, the try data structure is kind of getting used. So what do we have in that? So we have a root node, and each node kind of stores one letter and a dictionary based off of that letter. So say we have apple to be stored, then A, P, P, L, E. So each cell in the key element will have its corresponding dictionary, and so on and so forth. So even B would have its own dictionary, which would kind of keep a track of it. Yeah, maybe that's like a general overview of try. Let's see if we can start coding about it. You can take a look if you would want to read a little bit more on your own free time about try. Let's see if I can write a try code based off of this. So let's see. If not strs, if there is no strs, then return empty. And what are we gonna do? From collections import default dict, and we would do try equals lambda default dict of try. That's how basically you initialize try, and we'll start with root node. Fair. Now what we can start doing is for C in strs, wait, hang on, and the end characters is kind of marked as dot. So every word, so say if we have to store flower or flow, the way it gets stored is first it would have F, and the second layer would have L, and then O, and then W, and at the end it would be a dot. And for the flower, so F, L, O, W, there would be dot here, as well as E, and then there would be an R, and then dot at the end. So when we are searching through it, we'll search for if there is a dot. So that means this also is a word, and this also is a word. Okay, just if you are very comfortable with, just read a little bit about try if you really wanna know how do we kind of process with this. So we store for word in string s, let's assign t as a root which means like just the pointer. For character in word, T goes to root char, and then basically T of n. So each word kind of starts with that. So each letter inside the word, it kind of gets attached in the dictionary because it's a default dictionary, and then we kind of move the pointer to that dictionary and then start appending those characters inside the word. So first it will do F, then T would go to here, and then it will go to L, then it would O would be stored in L's dictionary, W would be stored in O's dictionary, and once the entire word is stored, the last letter is kind of marked with the dot. Fair? That's like a quick overview. And so what are we trying to do? Say we come out with this and we start building try for this one. So say we build D O and G and then dot, and say we have race car. So now we do not have anything that starts with D in race car. So in actual try, it will start storing R in the first layer of the root node as well. So R A, oops, and this one will kind of get built on top of like all these values will get appended in R's default it as well. So A goes in R, C goes in A, and so on and so forth. Okay, and again this one would have C. So what do we have to do? So we know that they have nothing in common. So if you start looking at the layer by layer keys, if the layer length is not 1, then we can just come out of it gracefully. What do I mean? I know, I'm sorry, if I'm confusing you, please leave me a comment. I know sometimes I tend to go really fast, but if let me see if I can explain. FLO W E and R, and then a dot at the end. This is the first flower for try. Second one FLOW, and then we'll store dot here. So we also know that there is a dot here as well, and FLI, so FL, and then there would be I, and I would have its G, and so on and so forth. Here okay, let me just do it right away. GH D, and there is a dot. Okay, so so to even find out the common prefix, we just have to check if the length of the number of keys stored in each level, if they are 1, then we are kind of appending it in the prefix. Otherwise we are just coming out. Make sense? Okay, so here if it is not, so we are coming out, no point going forward, and so on and so forth. Fair? So what we can do is say final results equals empty, while length of the root is equals 1, key comma value equal to list of root.items, and we are taking 0. So 0 means we are going layer by layer, and if k is not equals end, so if once the k is not, so if it's still a word and not dot, then we are appending results to k, and then basically root goes to root of key. Okay, and at the end we are returning the result. Okay, let's see. I know it's a lot to digest in. Whoops. Okay. Okay. Let's see. Where did we? For okay. Okay, this one should be t goes to t of care. Okay, there you go. Perfect. Let me submit this. Much faster, much better. Yeah, it's a lot to take in for try. But yeah, stick around for more such videos, and don't forget to like, comment, and subscribe. And stay tuned in. Thank you so very much.